No, I haven't given up. I wasn't gonna look my pet fish in the gills. I wasn't gonna look him in the eyes and tell him his species was doomed because we were all too lazy to learn a little bit of science and physics and make some hydrogen gas. Come on, you gonna let these non-renewable energies beat you like that? No way. If you're not gonna learn a little bit of science, you're not gonna save his species, and I just can't go for that, So I'm gonna teach you guys. So his species is at risk here. Because my species is too lazy. My species wants to act like an ostrich. That's what my species wants to do. They want to bury their head in the sand and clinch onto that phone. At least most of them do. But I'm going to show you guys some simple science. We're going to beat these non-renewable energies and these snakes. There's more energy in this fish tank right here than these guys can come up with. There's probably more energy in my bathroom. Let's go in there. So think about it like this. There's more clean energy in my toilet than you will ever get out of one of these things. All you gotta do is lower the resistance. Check this out. An endless amount of clean energy coming right out of the toilet. Now I know it's the most unlikely place to find an endless amount of clean power, but this is where it's at, ladies and gentlemen. It's been right underneath your asses the entire time. When you equate that in atomic terms and how much power that really is, it really is an endless amount of clean power. So sodium carbonate is one of the really good electrolytes that I use. And if you want, you can use urine right out of the toilet. You can pee in this thing. Think about that. And what happens is it produces hydrogen and oxygen and nitrogen on the other side. When you burn it, it just makes water. So you're still pulling apart the water molecule. It's always going to make hydrogen gas on your negative electrode. But you got to have a positive electrode that's made out of carbon fiber when you're doing electrolysis like that. We'll do a whole nother video on urine electrolysis, and I'll show you how that works. But I've been doing a lot of research on it. I'll show you a little bit in here. I'll have to make a whole nother video. So you're in luck. Get into that in another video. So you see the chemistry plays a huge part in it, what your electrodes are made out of. And that determines on what comes out the other end too. Whether it's pure water or something else. So you have to really know your chemistry. So when you're working with your wet cell, you want to make sure you understand what matter's made out of. You gotta remember what you put in the electrolytes, very important. If you want the positive electrode to make oxygen every time, you gotta have the correct electrolyte. Don't ever use baking soda. I don't use that, no baking soda, because baking soda is sodium bicarbonate and it has an element to it that could produce chlorine over at your positive electrode, so you don't want that in there. See, if you use sulfuric acid as an electrolyte, that's a liquid electrolyte. It produces an oxygen-hydrogen flame and it only produces water. So there's many different electrolytes you can use when you're working with a wet cell. And your negative electrode's always going to produce the hydrogen, but your positive electrode, you can produce many different gases. Remember, these are multi-gas generators. You want to be very careful what you put in there. You want to make sure you're producing oxygen at your positive electrode. So I think the best way to explain this is in my book here. Let me show you. You have to go back and read this. So it shows you that just like you, these electrons can remain excited or upstairs only for so long. Then they fall back down to their lower energy levels. That's what's happening to my reactor right now. It's a really cold day and the temperature's dropping in it. Even though I have it running at full speed, it's cold in this room. So when I turn it off, it cools down really fast. But I have all that electromagnetic radiation stored in the electromagnetic field that's creating this heat from the friction of the moving water molecules, but I also have infrared radiation that's there. And this is potential energy that you're going to use to heat other systems. Think about this. Here's one way to explain it. You have more energy upstairs. When you're on top of a building, you carry all that energy with you up there. And if you jump off, you'll be down here and you'll go splat, and all that energy will be turned into kinetic energy. That's what's going on in the water fuel cell here. You've stored up all that energy as heat inside with the water. Now you don't want to create steam. You want to have the water just hot enough where it's easy to pull apart. And that happens when you reach your peak resonance. 600 watts at about 23 degrees is where this particular wet cell reaches resonance at. It produces the most gas with the least amount of electricity consumed. And as long as the water temperature stays there, it can do that all day long. So this is how you produce the gas at a very economic rate, by elongating the water molecule and starting off hot instead of cold. To produce any flame at all, I have to have 150 watts starting off cold just to produce a tiny flame. It's potential energy. See, and this is where my fuel cell runs most efficiently. When you get your wet cell at the right temperature and at the right degrees, the right amount of electrolyte. But you can't stay there, see, it's climbing slowly. And if I had a moving water system where the system had moving water, you could adjust the temperature, and that would be key to having a HHO system. Because remember, HHOs burn as you make it. You know, you turn it on and you turn it off. So it has a lot to do with the temperature and the electrolyte. See this piece of ice right here? It's frozen. The molecules are very tight. They're very close together. Remember, a water molecule bonds to 4 others around it. So it takes a lot of energy to break that, to warm this water up. It takes a lot of energy. But once you get it going, then it becomes very easy to pull a water molecule apart into a gas. You elongate the water molecule. And that's perfect temperature right there for this wet cell. So here's the definition of electrolysis right here in my chemistry book. Those of you that want to read it. If you take a look at the ocean water here, you have to distill that and turn it into fresh water, because if you don't, you light that flame, what's going to happen is it produces hydrochloric acid. That's what's going to come out here on the other end when you produce that with that flame. That's element number 17. That's why you got to turn the salt water back into fresh water or you can't use it. So don't forget, when it comes down to measuring heat, temperature is just a measurement of how fast these atoms and molecules are moving. Think about that. I want you guys to see this right here. This is very important. It's in the Bible. Those of you guys that follow this stuff, I point out anything that I see that has to do with HHO gas or hydrogen or water molecules. And I noticed right here there was a lot of water splitting going on. This was in Moses' time, the Song of Moses. And this has a lot to do with Egyptians, pharaohs, water splitting. I mean, look right here, it has a lot to do with aliens too. I found some alien technology, and the angel of God which went before the camp of Israel, removed and went behind them, and a pillar of the cloud. So it talks about aliens going behind the clouds, you know, crossing the Red Sea right here. And Moses stretched out his hand over the sea, and the Lord caused the sea to go back by the strongest east wind all that night. Made the sea dry land, and the waters were divided. So there was a lot of water splitting going on in there. You know, Moses, he gave hope and power to the slaves. Think about that. Anytime I see this stuff, I try to point it out so you guys can see it. So I'm gonna show you a little bit about these electromagnetic fields, and you can see sine wave coming in here on the left. You can test it. You can see that oscillating electromagnetic field coming in for a sine wave, and it turns 120 volts into a DC square wave. So you don't have that field here, only over here. See, that's a static electromagnetic field right there. You can't see it, but it's there. It's huge. It's a massive field right there. I'll show you with two round magnets. These are speaker magnets, and we'll get that field rotating like centrifugal. I'll show you how that works. So you can see my two speaker magnets in there. I have them separated by a piece of plastic. I'm going to demonstrate the circular nature of the electromagnetic field that's here. So when you break apart the water molecule, the atoms are going to follow the electromagnetic field lines, because in a magnet the electrons are permanently in sync. Think about that. They're permanently frozen in time. And it has a lot to do with gravity here. This is a lot how a hurricane functions, and our universe is a spiral. So I'm going to turn this on here. This is 120 volts at about 1 amp. I wanted to show you the circular nature. You can see the atomic gas atoms spinning, just like in a hurricane. They're rotating. Maybe if I throw in some pepper, you'll notice a little better. So you can see there's hope for our little friend here and his species. With the wet cell hydrogen fuel cell technology, you can do a lot of different things with this. It has a lot of advantages a dry cell doesn't. So you guys are starting to notice that. So we're going to save his species. Advanced wet cell technology, that's where it's at, guys.